Hello guys, this is Tron Explains, and we have fluid mechanics question here, maybe to help you in whatever level of study you're in. Let's get straight into it. A pump lifts water from a large tank at a rate of 30 liters per second. If the power input is 10 kilowatts and the pump is operating at an efficiency of 40%, find A, the head developed across the pump, and B, the maximum height to which it can raise water if the delivery pipe is vertical with a diameter of 100 millimeters and a friction factor of 0.15. Well, let's start with question A. But here you should know this. I think it's about pipe pumps and efficiency, and maybe there's some formulas that can help you understand the question better. Number one is H is equals to pressure over density times gravity plus piezometric head plus V over 2G. This is just the head, and you can also then another formula to have of head is about the power, which is equals to density times flow rate times gravity times head, yani rho q g h, where this is density, let me see if I can zoom. Yeah, right. Q is flow rate, G is gravitational acceleration, and the H is head. Now, then we need to know something about the efficiency, which is N is equals to power out over power in. Now, in this scenario, we have in pumps and turbines, pumps are different from turbines in that pumps convert electrical energy into mechanical flow of water, right? And turbines convert mechanical flow of water into electrical. So if you want to know something like efficiency, where N here is just the efficiency. So N for turbines is equals to power out all over the formula I just wrote there, PQGH. Now efficiency for pumps, just switch, it becomes PQGH all over, but now it's power in. So just you'll get the power out from a turbine because this is the power in, it's coming in from the water. But for the pumps, this is the power being generated to the water from the power in. So this is just the concept I believe in. When solving or when wanting to find out something, you need to know where you are, the concepts you have, so that you can be able to solve the question more efficiently. Now let's go to the question. Head developed across the pump. So in the question we have, let's list the solution. We have the knowns. The knowns as Q rate, which is 30 liters per second. You can convert this into SI unit, which you divide by 1000, so that it can 0.03 meters cubic per second. It's always good to work with the SI units to make your need a lot easier. So then we have the power in. is 10 kilowatts equals to 10,000 watts. Then we have the efficiency equals to 40%, and you can always write 40 over 100 to avoid confusion. I'll show you where the confusion. So with this, you can now look at what formula you can use, which has most of the knowns. And for me, I'll use this one because the density we have, it's 1000 kg per meters cubic, right? So we have the density, we have the flow rate, we have gravitational acceleration. What we don't have is the head, and we have power in and power out. So the head developed. So we just substitute the efficiency, which is 0.4 is equals to density times flow rate times gravity times head over power in, which is 10,000. Do your multiplication. You get about 4,000, which is equals to P QGH. Now H will just be 4,000. You divide by the density times flow rate times gravity. Be 4,000 all over 1,000 times 9.8 times Q, which is 0.03. So H will become approximately 13.6. It's approximately 13 point something like over 6. So let's go to the next part, which is the maximum height to which it can be. There is the water in the delivery pipe if the pipe is vertical, and diameter is this, and friction factor is that, right? What the concept to understand there is that when the pipe is vertical, it can only raise the water according to the head that you've calculated here, and this will help you because there is, to get the head loss due to frictions, you can only use the Darcy's equation. And the Darcy's equation is just FLV squared all over 2GD. Now F is the friction factor, L is the length of pipe, V is equals to mean velocity, G is just gravitational acceleration, and D is the diameter. So, and to know the maximum head, it's just the head developed, you less the head loss due to friction. So let's come here. What in our formula we have the friction factor, which is this. The length of the pipe, I told you, as the pipe is vertical, the head produced by the pump that's the only length that's the only length the pipe can be. If the head produces 10 meters, your pipe can't be more than 10 meters, otherwise it won't be effective. So the length of a pipe, you just take it as this head you got here, and V squared to calculate the mean velocity, you just use the formula Q is equals to A, which is cross-sectional area, V, so V it will be Q over A. So let's just do everything. What else don't we have? G and D. So V is equals to Q over A. So A it will be pi D squared over 4 equals to pi D, which was 100 millimeter. millimeters, so we can convert them into meters, which is times 0.1, because it's divided by 1,000. That's 0.1 meters squared all over 4 to give you the area will be. So after you feed these values into the calculator, you get your areas 0.007853 meters squared. So V is equals to flow rate over area. Feed the flow rate, which is the flow rate is 0.03 all over 0.00783. You can store this value on your calculator to get I like rounding off in the last in your answer, maybe to get more accurate. So just shift store in your calculator. So you get this at meters as the velocity. Now head loss due to friction uses dashes, whatever you call it, formula, which is up here. FLV squared over 2GD, FLV squared over 2GD. So it will be 0.015 times the length. Now this length is not given in the equation. You'll have to use your intuition that if the pump just pumps ahead of 13.6, you can't even, and also here we're considering the head losses, meaning you can't even pump beyond that 13.6. You'll be capped by 13.6, and now we are calculating the head loss. So L will always be the head generated by the pump, that is, times what's our V is 3.8197 all over 2 times 9.81 times 0.1. Feed this into your calculator, you should get something like 1.517. This is the head loss due to friction. So to get your max height is equals to head minus head loss with friction, because now it's a loss, right? It will be less from the overall head, so it will be 13.6 less 1.517. This should give you 12.08 meters. Yeah, like and sub for more. Cheers.